Good morning. Today I'm subbing and I found this book called The International Space Station by Franklin Branley, illustrated by True Kelly. And the introduction is by an astronaut, so we're going to read that first. The astronaut's name was Scott Carpenter, and he was a Mercury astronaut. It says, "For thousands of years, people have wondered what the moon is made of. We found the answer in 1969 when astronauts landed there. But before we could fly all the way to the moon, we had to learn to fly in orbit around Earth. This was the goal of the Mercury program, and it succeeded. In 1962, John Glenn was the first American to orbit the Earth. I was the second. It took many men and women many years to learn the thousands of things we needed to know before we could reach the moon, but we finally got there. We had taken our first giant step into outer space. Now we are about to take another big step with the International Space Station. In the Mercury capsule, I was in orbit 4 hours all by myself. The space station will go around the Earth for years, and teams of 6 or 7 people will live and work there for many months. They will do research to find out the thousands of things we need to know before we can explore our solar system and the galaxy beyond. One day, the space station will become the first step toward a mission to Mars. You may be part of that mission. How lucky you are," by Scott Carpenter. In December of 1998, 2 astronauts floating in outer space fastened together the first 2 parts of the International Space Station. The Russian part was called Zara, which means sunrise. The American part was called Unity. Together, Zara and Unity were as tall as a 77-story building and weighed 77,000 pounds. But that was just the beginning. That is huge. I had no idea. Oh, here's the Unity from the United States, and here's Zara. I might not be pronouncing that correctly, and this is from Russia. The International Space Station is still being built today. It has thousands of parts. Some of them are capsules or cabins that are fastened together. There are capsules called habitats where the crew live. There are laboratories and experiment capsules where they work, and capsules for storage, communication, and more. The backbone of the station is a long piece called a truss. It holds everything together. Astronauts use the truss to move from one area to another. All the parts of the station are made on Earth. Bit by bit, they're loaded aboard cargo shuttles and rockets. The shuttles and rockets blast off, go into orbit, and release the parts. The shuttles then return to Earth for another load. After the parts of the station are in orbit, they are put together. That's the special job of spacewalkers, men and women who have been trained to work where there is no air or gravity. Robots do some of the work outside the station, but spacewalkers do most of it. Spacewalkers must wear spacesuits to keep them from freezing and from boiling. The suit also has air for the astronauts to breathe. A person can stay in a spacesuit for 8 hours. The suit keeps pressure pushing on the astronaut. Here on Earth, air pushes in on our bodies all the time, but we don't feel it because there is air inside our bodies pushing out. In outer space, there is no air pushing in, but air inside a person is still pushing out. So without a spacesuit, the body would swell up. It would push out farther and farther, and astronauts would burst. You can pause that if you want to read the different parts of the spacesuit. Spacewalkers are tied to the station by a tether. Tools used by the spacewalkers must also be tethered. If they weren't, they would drift away and be lost. It says, oops, I dropped the screwdriver. Spacewalkers move by pulling themselves from one handhold or foothold to another. They have to put their feet in footholds when they use screwdrivers or wrenches. If they didn't, it is the spacewalkers who would spin around instead of the screws or the nuts they were trying to tighten. In several years, the International Space Station will be finished. Here's another one I'm just going to put up, and then you can pause the video if you want to study it a little more. It does say that the space station is about 250 miles above Earth. The station will be more than 350 feet long as a 30-story building is tall. It will weigh about 1 million pounds. It seems as if something that heavy would fall down. And actually, the station does. As the station circles the Earth, it slowly gets closer and closer to the planet. If it weren't boosted back up, the station would crash into Earth. That's why there are small engines on the station. They help push the station back into a higher orbit when it slows down and moves closer to Earth. The Russian Progress resupply vehicle acts as the station's booster. The space shuttle can boost the station too. Almost everything on the station is run by computers. Those computers use a lot of electricity, and it all has to be made on board. The large flat sections at both ends of the station are the solar panels. They make the electricity that runs the station. Pretty cool. Those are the solar panels. Solar cells cover the solar panels. The cells change the energy of sunlight into electricity. There are never any clouds in space, so unless Earth is between the station and the sun, there is always sunlight. When the station is in Earth's shadow, lots of batteries are used for electricity. They are charged while the ship is in sunshine. And it says 1/3 of every orbit will be spent in Earth's shadow. Every day, the station sees 16 sunrises and 16 sunsets. Well, that's mind-boggling. There are smaller flat panels at right angles to the solar panels. These are the radiators. The station gets very hot when it is in sunlight. The extra heat is collected and carried to the radiators, which are turned away from the sun. Heat travels from a hot place to a cooler place, so the heat in the radiators leaks into the intense cold of outer space. What if there were trouble on board the station? The station might be hit by a meteorite, or something could go wrong with one of the computers. That's why there will be an escape vehicle called the X-38 on the station. It looks a little like a high-speed boat, and it could carry all the astronauts safely back to Earth. The X-38 has a large parachute to make an automated landing. No pilot is needed. It does look like a little speedboat, doesn't it? Men and women from the United States, Japan, England, and Russia, and eventually from 16 other countries, live and work on the station. What do they do? The first thing they do is try to stay healthy. There is air inside the station, so the astronauts do not have to wear their space suits. But the crew is still in outer space. They are in zero gravity, or very close to it. They float in space. Their muscles and bones don't have to work very hard as they stand, sit, or move about, so their muscles and bones get weak. It says people in space get taller because no gravity pulls them down. The crew must exercise a lot to use their muscles. Usually they use machines. They also eat good food. All of it is sent to them from Earth. A lot of the food is dried and water is added to it at mealtime. However, the crew of the station also has fresh fruits and vegetables brought by the shuttle. No one sits down for a meal. In place of chairs, footholds keep the diners from floating away. The shower has a cover to keep water droplets from floating around. They could be dangerous if they got into the electronic computer equipment. Water doesn't flow when there is no gravity. So when the astronauts take a shower, water from a hose is rubbed on like lotion. When it's time for bed, the astronauts crawl into an anchored sleeping bag so they don't float away while they're sleeping. That is fun to think about, isn't it? And the water is like lotion that they have to rub on. Did you see what she was dreaming about? That's something I would dream about. Hot Fudge Sundae. The astronauts on the station do research to find out more about outer space. They can grow perfect crystals to study back on Earth. You can't grow perfect crystals on Earth, only in space. They can make alloys, mixtures of metals, that are better and stronger than the ones that can be made on Earth. And they will study themselves and each other's to find out what happens to people who live in microgravity. This will help us get ready for trips to other planets like Mars. So here's a picture of astronauts doing an experiment to see how their lungs work when they're in space. We don't know what the astronauts on the space station might discover. That's part of what makes the station so exciting. Here's a Japanese model, and I'll just put that up for a second. You can study that if you want. Someday the station could even become the starting place for spaceships bound for the moon and Mars. A ship that takes off from Earth cannot be very large or very heavy because Earth's gravity is so strong. But the station has almost no gravity. A ship launched from the station could be larger than one launched from Earth, and it wouldn't use nearly as much fuel to get going. The International Space Station is the great adventure of the 21st century. Watch the sky for the station. It will get brighter and brighter as each new section is added. From time to time, you will see it fly by. Someday, you may be a crew member aboard the International Space Station. Then, people on Earth will watch you fly by. Here they're out camping. Oh, wait, I see it. Have you seen it go by? I haven't. Here is a recipe if you want to grow your own crystals. So I'm going to put that up. Okay, I hope you enjoyed this book. If you do make the crystals, let me know.